a startup called Earthmover. Today I'm going to be talking about Icechunk, a storage backend for Zar that we've been developing. And I'm going to specifically be talking about what's coming in Icechunk 2 in the second half of the talk. So, okay, a little bit about Earthmover. Earthmover is a public benefit corporation founded by myself and my co-founder, Ryan Abernathy. And we have a mission to help people use scientific data to solve humanity's greatest challenges. We mostly focus in the climate, weather, and geospatial space. Our mission is broader than that. Someday we might also solve problems in biology and medicine and that sort of thing. But our team is a mix of engineers and scientists that have gotten hooked on building software and data tooling for a really wide range of scientific applications. We got our start through the Pangeo project, which I'll say a little bit about after, and worked on open source software projects like Zar and Xarray. So a bit more about our open source stack, if you will. This is what we kind of think of as our open core at the company. I got my start in software working on Xarray. Anyone in the room use Xarray? Woo! Yes! Okay. Friendly faces. So yeah, it sounds like most people know what Xarray is. It's a data model and a toolkit in Python for working with multidimensional arrays. It has a rich API and kind of similar to NetCDF and Pandas kind of jammed together. From there, moved on to working on Zar. I'm wearing the Zar t-shirt today. Heard a little bit about Zar. Anyone use Zar in the room? It's going to be less for now. More hands next year, I promise. So Zar is a data format for storing large multidimensional arrays. It's cloud optimized. It has a bunch of different compression codecs, very flexible in how you organize the bytes on disk and your hierarchy of data. And it's really built for parallel access, both reading and writing. And then at Earthmover, we've been working on a new project called Icechunk, and that's the focus of this talk. It is a transactional storage backend for Zar. And so I'm going to tell you what that means in this talk, but it's bringing in some ideas from database land into the Zar ecosystem. So before I jump into what we've been working on lately, I'm going to tell you a little bit about where we came from. I mentioned the Pangeo project. So a number of us, I wasn't alone, I wasn't the only one that started it, but back in 2016, started the Pangeo project, which was meant to be this kind of community effort to integrate software and data tooling for the geoscience community. And it's how we got our start in the cloud. And it really had like, I gave this slide, I don't know, 1,000 times already in my life. This went in a proposal to NSF in 2017, and we used it over and over and over again. But the basic idea was find a way to separate storage and compute, store data in a parallel backend, like object store, scale your compute elastically, and then give users a nice thin client, like Xarray, in a Jupyter notebook or something to work with that data. And people loved it. They loved various parts of it. Some parts have kind of faded over time. Some parts have gotten, have changed quite a bit. But this was the architecture diagram. We call this kind of a reference architecture. It doesn't actually tell you how to build anything. It's just, the dream. Okay, so I'm going to mostly focus on the data storage and data backend part of that stack today. So I'm not going to talk a lot about Xarray and parallel computing or anything like that. I'm really going to talk about Zar and Icechunk. And Zar is today, the emoji is different on this computer, by the way. Zar is being adopted really widely today. And this is just some of the logos. I put logos on here that I thought everyone would recognize. But there are many other companies and smaller research organizations that have adopted Zar at one level or another. The big one here is that recently, ESA and the Sentinel Archive is moving to Zar. going forward. And so there's just about to be a lot of ZAR data in the world, which is great. One of the main theses in my talk here is that ZAR solves some important problems, but it leaves some pain for you all to deal with if you're going to use ZAR. And that's pain that we're trying to solve at Earthmover. So I'll tell you a little bit about that pain. The first is there's still a tendency to get a data swamp with your data. And so you might have a bunch of ZAR data, you might put it in the cloud, but how are you going to organize that? How are you going to catalog it? How are you going to do data provenance, data versioning? If your data sets are petabytes in size, how are you going to coordinate who has access and when they were updated and all of that sort of thing? So when we talk to customers at Earthmover, we often leave the conversation feeling like this is actually an architecture diagram for what they're trying to do. So want to help them solve that. ZAR is also not really built for concurrent multiplayer mode. And so here is an example where you have a user A who starts writing a big update. Meanwhile, user B starts reading some data. And they're both operating on the same array at the same time. And the behavior in ZAR is undefined about what data user B will get. Will they get the array at the start of the write or the end? There's a chance for corruption in that case. There's just a bunch of like gotchas if you're going to like put ZAR inside of a production pipeline. And so that's a pain point. Finally, there's this promise of peak performance with ZAR. This is literally from our marketing website. You can put your HDF5 files in the cloud and you get slow performance. You put them in ZAR, you get fast performance, and this is possible for sure. But in reality, there's hundreds probably of GitHub issues that look like this. Poor performance when slicing, repeated appends are slow, ZAR is slower than H5Py. There's all sorts of these out there. And what this has really taught us is that there's just a lot of ways to go off the rails. And so that's a pain point. And then finally, schema changes are really hard. You have this arbitrarily shaped hierarchy of arrays inside of groups, and moving data around inside of that hierarchy, changing things like the name of an array, changing the chunk grid and how it's laid out. All of these are hard, and mostly that's because we use the storage backend for some of the encoding, right? So like the name of the chunk is just like a key in S3. And so if you want to move that array, you have to move all the chunks too. And so that could mean moving petabytes of data. Okay, so my conclusion is that we need something that looks more like a database for our array data. And I asked Gemini to communicate that to us, and this is what I got. It turned out a little more like slimy than I was hoping, but the idea is that it's easy to end up with a pretty complicated mess of data, and ZAR doesn't solve that for you. And in many ways, it's just like another file format that's out there with some real advantages, but also some drawbacks. Okay, so NWOC's Icechunk. Icechunk is an open source cloud native transactional storage backend for ZAR. So that's a mouthful, and I'll explain what all that means. The first thing is it provides ACID transactions. So these are atomic updates, consistent updates that you can apply on top of your ZAR operations. And so there's an example here in these 3 lines where you say, with repos, this is an Icechunk repo, .transaction on the main branch. So there's a branching strategy that looks similar to Git. In my commit message, when this transaction is done, open the group and write some data to this foo array. And this is done atomically. Only when that transaction finishes, our new reader is able to see that. And it's also reversible. If an error happens in the middle of this, we didn't overwrite any chunks. So yeah, we have all the, along with these ACID transactions comes data versioning, branching, conflict resolution, all this kind of, many of the same things you get with Git. It's written in Rust. We get a nice performance boost on top of ZAR just by using this. It gives you a ZAR store interface. And so right here, you just pass in a ZAR store, so anything that uses ZAR Python or the ZAR's REST library can just use Icechunk as well. It's built for the cloud, and it's Apache licensed, 100% open source, runs entirely in an object store, so there's no extra server or anything like that. So a couple, I think I just have one case study. We did a project with NASA and Development Seed last year where we helped one of the groups that was trying to migrate the Giovanni data service to the cloud. And they had started moving netcdf files into a cloud bucket, and they were really struggling with query performance, trying to drill through a bunch of archival netcdf files to pull a time series from a satellite archive. And so we brought Icechunk in. We incorporated those netcdf files through virtualization, so we didn't actually copy the bytes. We just scanned those and stored them in Icechunk. Scanned the indexes and stored those in Icechunk. And we went from their on-prem performance for this query was 45 seconds, which is pretty slow, but to get a month of data, that's what it took. In the cloud, it was taking 5 minutes to pull that same time series, and then using X-ray and Icechunk together, it took 3 seconds. So they were pretty happy with that, and so are we. So it's zippy. So, okay, Icechunk 2. So Icechunk 2 is the next version of the Icechunk library. We released Icechunk 1 earlier this year. So we're evolving the format in the API. And I'm going to explain what has changed since then. So the first is we learned a bunch of stuff. So people have gone and adopted the first version of Icechunk, and we found some more gotchas. And so that's what Icechunk 2 is meant to do, is kind of solve some of those. The first is we saw our customers building really complex hierarchies with thousands and thousands of commits. And now we have a hierarchical data format and a hierarchy of versions that are possible, and that caused pain. So Icechunk 2 is meant to solve some of that. Those big manifests and version histories are hard to carry around in Icechunk 1, and so we're going to work on that. We also heard that people wanted to know, like, when was a branch created or deleted, or like when was a tag created? So the ability to audit the whole archive, not just individual parts of the ZAR hierarchy. People want to do more complicated schema evolution, and so things like prepend or rename to an array. Those are things that Icechunk is in a good position to do, where they're pretty hard to do in ZAR. And then finally, more flexibility around the transaction. So I showed one type of transaction. And one thing we've learned is that with data versioning, you have transactions and you have versions, and in Icechunk 1, they're the same thing. And so you always get a new commit anytime you close a transaction. But most people don't actually care about the incremental commits. They care about versions at some other aggregate level. And so helping people achieve that. So yeah, what's new includes a new on-disk schema. So we're going to change the spec. We've implemented move and rename, so you can shuffle around your hierarchy without actually copying any bytes. So that's basically a free operation. There's new API for auditing, session committing, and then use on just direct HTTP servers. And the final thing is that Icechunk 1 will still be supported, so it's backward compatible, and you'll be able to continue to read and write Icechunk 1 if you have that. So a couple code examples. This is what it looks like to move data in an Icechunk store. So we have what's called a rearrange session. This is a special type of session that allows you to move data around. So we can move the foobar array to the VAS group here in line 5. Then we can move that same array again to the root, and then we can make a commit. And so full flexibility on how you kind of organize your hierarchy. This is the how you do a prepend. So in ZAR keys, your chunk grid starts at 0 and goes forward along each axis. And if you want to add data before the start of the origin, there's no way to do that. The only way to do it is to rewrite the whole array. And so what we've done in Icechunk is done a manifest operation that allows you to first resize the array using ZAR. So this adds dimensionality. And then shift by an offset. So this slides the whole array over 10 chunks worth. And then you can write to it. And I didn't show the commit, but it's the same session.commit as before. Great. Okay. So natural question is, so how are we using Icechunk at EarthMover? And so this is our architecture slide at EarthMover. Kind of shows how all the pieces fit together. But yeah, we're a cloud platform built on top of ZAR and Icechunk for cataloging, governing, and distributing ZAR and Icechunk data. So our customers bring their own cloud provider, and then we come in with our platform. Array Lake is our data lake layer, and Icechunk is the format that's stored behind or under the hood. And then we provide the catalog and governance, and then a set of community-supported, like OGC style APIs on top of that. So that's how we use it. And then to summarize, some of you probably haven't heard of Icechunk, so I'll just repeat something I said. Icechunk is a transactional storage backend for ZAR. It solves data versioning, performance, and schema issues. It's cloud native, and it integrates with the whole kind of scientific Python stack and a bunch of storage backends like S3 and Google Cloud. Icechunk 2 is a new version of the specification and a new library. It's about to come out. We have an alpha release out already. There are new features in it, things like move and rename, insert and append. I showed prepend, but you can also do things like insert or append in similar ways. And then a bunch of tools for like history management and auditing. And it's the documentation and everything for Icechunk is at icechunk.io. You can use the QR code. And I think, here's my last slide. So I'll take questions. And I have a couple Icechunk and ZAR stickers left. If you want one of those for your laptop or whatever, come say hello.
Does anybody have a question? Please, speak now. No, yay, thank you.
I guess like everybody overwhelmed by all the things you can do. So you could also use Icechunk without Xarray, right?
Yes, yeah, totally.
So
yeah, you can just use the ZAR, like a ZAR API, so ZAR Python, or we have a bunch of folks now using the Rust version of ZAR with it as well.
Yeah, so I've heard a lot of people talking this week about using ZAR for storage and Stack for discovery.
Yep.
Do you have any sort of capacity to include updating your Stack item transactionally with the update to the ZAR storage?
Yeah. So directly today, no. But it's possible to use Stack to reference an Icechunk store, just like you can reference a normal ZAR store, but combining the transaction of updating your Stack item and the Icechunk item is a different problem and is one we haven't touched. So. There's another question.
I was just in the talk for CART, the data versioning control for mostly vector and tabular data.
Okay, yeah.
So is the analogy right that Icechunk is doing something similar, version control?
Yeah.
It's because how would you, I don't know, see versions, and you also use like commands, like, or do you always have to open the store and then look? How does the catalog stuff work? Also, probably in reference to Stack, like.
Right. Yep. So yeah, the on-disk representation of the version history, starts with an entry point, and then there is this, a branch pointer that points to the history log, and then from there, it is itself a hierarchical format. And so I didn't mention this, but like the data versioning is diff-based. So if you just write a few more chunks or add one new array, you didn't have to rewrite the whole store for the version, so it's storage efficient. So how it's all stored under the hood is somewhat of an implementation detail, but it's there's a manifest for each version.
So the store itself contains all the different ZAR data sets that you sort of maintain in that version control. Is that maybe?
Yeah, and if there's overlap in versions, then we only store the unique parts. But yeah, there's a way in Python to like list out all the versions and see the commit log essentially.
So I would have to be careful that I don't build my own data swamp again by having many of those Icechunk stores.
Sure. Yes. I think I see what you're saying. Yeah, you would still have to organize your data in a catalog of some sort. So that could be Stack, or it could be we have a catalog that also is a catalog of Icechunk repositories.
Great. Would you like to join me in thanking Joe?